And now it's time for A Geek Speak with
GK Technologies,
Sarah and Jody.
In the fields again, I just can't wait to get in the fields again. The life I love is spreading potash for my friends, and I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Welcome back to A Geek Speak. We are having just a very fun conversation today, continuing on from last week, where we're visiting with the great Tom DeSutter. Last week, we visited about Tom's background a little bit. We visited about the 5 soil forming factors and just a number of things. If you haven't had a chance to hear that episode, I encourage you to go back and check it out because it really does set the stage for today quite well. But let's jump into it. You know, one of the things that we had talked about a little bit at the end of the conversation was how the landscape really determines how things are different in different places. And one of the things that we did not get a chance to talk about last time was really that concept of soil type and how soils change. One of the things that in conversations I've had with a number of different people is I don't think people generally understand that soils have a classification system and just how different soils are when we start thinking about, you know, some of the different soil orders that actually exist. There are 12 soil orders that exist in soil taxonomy, and they all mean something very differently. And the reason I'm even bringing this up is because in North Dakota, we have a few different soil types, but generally when we think of North Dakota, we think of prairies. And that's all we think about. And it's just going to be the parent material of prairies. But especially on the east side of the state, in the Red River Valley, we've got what's called a vertisol type soil, which is a very, well, some people call it a heavy clay. I think Dr. DeSutter might say, how heavy is that clay? Which is fair. But let's just be real. It's a very unique soil type that we've got in the Red River Valley of North Dakota.
So, Jody and Sarah, thank you again for bringing up the conversation. You know, because it was last week, I guess, on the recording, one of the things I've noted to both these two fine students, former students, is that every year my class is new, and partly because I don't remember what I talked about the year before. And so what we talked about last week was a little bit about reading the landscape, right? That's the word I remember. And so, but one of the things that, you know, we talk about or think about is like, how does soils form? Why do they form? And then what are the resulting properties due to that formation? And so what Sarah is alluding to is that, you know, we do have in the Red River Valley across North Dakota, you know, we have different soil orders, mollisols and vertisols and entisols. And these all stem from what's called soil taxonomy. And soil taxonomy was developed not unlike the Latin system for identifying insects and plants and everything else. So a lot of these terms that are used in soil taxonomy have their roots in Latin or Greek. And so if you think about the fine loamy mixed superactive haploudol, that doesn't mean a lot to a lot of people. It sounds like, well, that sounds Greek. Well, it's like, actually, a lot of it is, because there's a lot of Greek terminology in that. So you can actually say that, and it's actually true. But that's how we identify these soils then helps people like Sarah and others think about the properties and think about whether or not those properties are going to be conducive for crop production or not. And so the vertisols, as an example, we think about these as like having so we have different types of clays too, and that it gets all complicated, right? And it's like, oh, I thought this was easy. And it's like, well, it sort of is. But part of it is you have to have a base knowledge of like what these terms mean. And so things like, you know, smectite, you know, we think about smectite and chlorite and kaolinite and things that these are the clays, but these are the clays that actually drive the soil properties. And so smectite, as an example, is a shrink swell clay. And so those of you that have soils, and you've seen it time and time again, when you get into August, oftentimes the soils form this big crack. and that's the clays dehydrating. That means that most all the time the soils are hydrated in some way, but as that water leaves, the clays tend to contract. And when they contract along fault lines. And when they contract along fault lines, you get these big cracks. And that's when you see vertisols, meaning invert. That means soil falls down into those cracks, it hydrates back up again, and it closes back up. And then 5 years later, it opens up again because of drought, and things fall back down again, and so on and so forth. And so vertisol, meaning invert, is an example of what we describe as a high clay soil with a shrink swell of characteristics. But most of these soils that we're talking about are very highly productive, and they're highly productive because plant productivity over the course of thousands of years has put a lot of organic matter into these soils, and that's where a lot of our productivity will come from.
I think it's really interesting to bring that up. One of our conversations from last week was talking about how farmers interact with their different landscapes and the decisions that they have to make based on what their locations are. And in a lot of these vertisol type soils in North Dakota, for example, are right in the Red River Valley. My favorite soil type, I'm just going to say this, point of personal privilege here, it's the Fargo clay. And I'm sure that there's a ton of farmers out there that are going, really? That loon poop? What are you thinking? Because it's also a very difficult soil to work with as a farmer. But it is the soil that's right in my backyard. And I will say that to a certain point, I think farmers that are farming in that soil type, they've got a very different way of thinking about planting that farmers who have never experienced that soil type before. Because if you do tillage on that soil at the wrong time, you create a lot of extra dirt lumps in that field. And that becomes very challenging to make good seed beds out of. So it's interesting because I have seen it many times right here in my backyard where the farmers to the west of the valley might be going up on the ridge where we have the non-vertisol type soils. And yet when you come down into the Fargo clays, the farmers aren't going because they know that if they go out and start working with that soil at that point in time, they're going to make a really big mess and it's going to cost them a lot of yield at the end of the day. But to have that patience to know that even though it looks like you could do something, that they'll sit back and they'll wait when their neighbors out west are out working the ground and making things happen. It's just really an interesting thing to see. Honestly, it's been one of the things that I've always thought was really interesting about agronomy when you're trying to work with farmers in different places and different landscapes on different soils.
Sarah, you bring up a good point, is that, it's almost like a trafficability map, and it's based on soil series or soil types of soils, right? And so when it's too wet, it's too sticky, it's, your trafficability just goes down. But if it's too dry, like we talked about, and you bring up, and the soil is just too hard, the trafficability is just fine, but the cultivability of that soil is shearing a lot of bolts, and so it's just an interesting problem that is not unique to North Dakota, but it's not uncommon in areas that have vertisols that have these high shrink swells. So
I want to ask you too, because you went to school at SDSU. And I think there are some vertisol type soils in South Dakota. And certainly we have a clientele down in South Dakota as well. Can you talk about where some of these vertisols might be occurring in South Dakota as well?
I'll use maybe an example, so the Red River Valley of Texas and Oklahoma, okay, right? So we're talking about lower lying areas that may have, not necessarily annual flooding, but maybe there was some depositional things when the soils were formed or created. So not unlike the bottom of Lake Agassiz, things settled out over time, and the last things to settle down were the clays and the silts. And so that's where you tend to have, in some ways, a higher concentration of clay in these areas that were old lake beds, or maybe riverian areas that are older. But that's where they are, maybe along the Big Sioux River basin, things of that nature, which I actually grew up along the Big Sioux River in Iowa. But we had more of the loess, the windblown deposits in that area. And so very highly productive soils. Iowa has been blessed by very good soil, very good soils and very good rainfall, and which is why it does really well in agriculture. And so,
I forget, Les, what order are that? Is that also mollisol, or is there another order that the windblown deposits are?
yeah, it would be classified as a paramaterial.
Okay.
I don't think it necessarily has to have an order to it. But as a fun fact, if you went to Puerto Rico, those of you that are thinking about vacationing, Puerto Rico, the island, out in the middle of the Caribbean, it has 10 of the 12 soil orders. And so if you can find yourself on a tour, a soils tour, you can visit everything but gelisols, which are the cold ones, which people from Puerto Rico would probably move to North Dakota if that was their soil order.
Permafrost is a gelatol.
Yeah.
Okay.
Yeah. And then the andisols, which are the volcanic. And so, but you can go down to Linton, North Dakota, and you can find all the volcanic ash you want, right? I mean, there's a huge deposits of volcanic ash.
I did not know that.
I can hold some up. That we actually went and collected a bunch to see what kind of, because oftentimes these oxides in these, like iron oxide as an example, has a really high retentive for phosphorus. And so we have read that this volcanic ash also can retain phosphorus. We did a bunch of studies here recently, and the volcanic stuff, even though it does have some iron oxide in it, it's mostly silica oxide and other things, alumina oxide. Doesn't have a lot of good retentive properties for phosphorus, but we got a bunch of this mining ore byproduct, and it's about 30% iron oxide. And so when you're thinking about parent materials and where soils come from, understanding a little bit about these properties helps you manage your fertilizer too, right? If you have a high calcareous soil in a field, your phosphorus retention creating calcium phosphates, the odds of that are much greater than they would if you don't have that free calcium in those systems. So not only do the work we do is related to environmental work, but it's also applicable to these landscapes and how you manage these fertilizers.
Can we talk a little bit about that too, and maybe pH? That is the drum that I will constantly beat, but I think it's important to talk about because it also discusses some of these other like soil types and things that affect pH. And sure, like for the most part, in a mollisol and a typical prairie profile, right, we have a lot of that calcium carbonate. Probably not going to have to worry about acidic soils, but we have these acid soil issues. And I'm curious, what types of areas would we typically see, or what kind of landscapes or parent material would we expect to see a higher incidence of acidic soils, or which ones are more prone to become acidified over time in a cropping system here in the Northern Great Plains?
Yeah, I certainly think the ones that have plenty of calcium in them, like lime, the odds of seeing acid soils in Walsh County or Grand Forks County have got to be pretty small, right?
Hey, and Sarah works at a farm just north of my house. And I live on an old Lake Agassiz beach line in western Grand Forks County. But Sarah does have a farmer with
you did.
OPH.
Yeah. And I've got some that are 2 miles off of I-29 by Hillsboro.
Small percentage of overall Grand Forks and Trail County. But
I mean, you have to grid sample to find them.
Are they in the fives or are they in the fours?
Fives.
Okay. Yeah. I mean, I've seen some stuff south of Dickinson that we sampled that were like 4.5. And so, but we kind of looked for the aluminum. So as you get lower in pH, right, you have more exchangeable aluminum and then more hydrogen, because hydrogen is really the pH is a term called the power of hydrogen, right? But it's also the negative log of hydrogen is really what you're after. And so even a tiny concentration, 1 times 10 to the minus 7th moles per liter, which we won't worry about the units, at this point, that's a pH of 7. And so a pH of 5 is 1 times 10 to the minus fifth. And so that's a pH of 5. And so as you alter that hydrogen concentration, that's what drives the pH. That driving of the pH is what drives nutrient availability. And so even these small little changes can make a big difference in sort of like the availability of phosphorus is the main one we talk about, right? And then the toxicity that aluminum 3 plus would have on roots themselves. And so managing these acid soils is and will be complicated, right? By the fact that you have arid environments. The most common thing you do is apply lime, which is calcium carbonate. If we think about the solubilities of salts, if you think about gypsum, which is commonly talked about as being a liming agent, which it isn't, do not apply a gypsum if you think you're going to change your pH.
Can I just reemphasize that, Tom?
Yeah, go ahead.
If you guys did not hear that, do not apply gypsum to change your pH.
No.
There you go.
There, set it. Right, we got to set it. Anyway, and so, but the solubility of gypsum is like one US penny in a liter of water. So 2 bottles of water that you buy at the, those 500, those plastic bottles of water you buy by the case, 2 of those. And so, but the solubility of calcium carbonate is like 35 times less than that. So that's almost like taking the face off of Lincoln off the penny, and that's what will dissolve in that much water. And so that's the complication of in the western part of the state is you don't have enough water to actually dissolve to make dissolve that salt into calcium and carbonate. The calcium is used to help remove the aluminum and the hydrogen off the soil exchange sites. The carbonate is what neutralizes then that hydrogen, creates water, and eventually creates water and carbon dioxide. And so if you don't have water, as we talked about before, water is the great equalizer. And so how do you manage water and keep water and get more water into the profile? That's the biggest challenge, especially in arid and semi-arid environments.
Okay, another question I had kind of related to that. We talked a lot in the last episode about just salty soils in general and why here in the Northern Great Plains we've got more of them in other places. I'm curious, we've talked about calcium carbonate, lime, we've talked about gypsum, another salt, calcium sulfate. Can you talk more about what are the other common salts that we have here? Because I think when people think salt, they think table salt, right? So sodium and chloride. And a person might think, oh, if we're talking about salts in the landscape, we're probably talking about sodium chloride. So we're going to have acidity in the field. But that's not the case. Can you tell us more about what our common salts are here in the state?
Okay. So we go back to the point of what a salt is. And a salt is an anion and a cation. And so in non-aqueous, non-water conditions, a salt is a crystal, right? Not the crystal, the big, wedding ring sort of crystals that you can buy now that are manufactured, but these are crystals that form naturally. And so back to maybe a conversation of on your, it's a hot day, you've been sweating all day and you take off your hat and it's wet and then you let it dry. That's the salt that is crystallizing on your hat. And so that's what we have in the soil. And so we have salts that are magnesium sulfate, calcium sulfate, sodium sulfate, some sodium chloride, calcium carbonate, of course, which is a very sparingly soluble. But those would be kind of like the main ones that we would consider to be the ones that are most influential in crop production. And so as we think about like how impactful they are, there's a lot of really good crop production that is in calcareous soils. You can see the line, but there's a lot, it is like good production, right? And so, but the problem, the reason is those that when it's wet, that calcium and carbonate isn't negatively impacting the plant, right? And so if you have things like magnesium sulfate, which it takes almost, like a handful in a liter of water, and that's how much will dissolve, where you can actually don't see any particles in that water. Well, that's a lot different concentration in the soil that's solubilized than it is for calcium carbonate. And that's why the solubility of salts is what impacts eventually crop production. And so like calcium sulfate, which is gypsum. Again, it was that 1 penny size in a liter of water. You can farm in calcium sulfate enriched soils, not a problem, right? I mean, it's you have calcium and you have sulfate, and they're both like necessary plant nutrients. But they only, because its solubility is so low, it doesn't negatively impact, plant production. So
That's such a great point, because we talk about calcium carbonate as being a salt, but we really shouldn't worry about having too much of it, but besides maybe having to apply more phosphorus because it can tie up phosphorus at the higher pHs. But like you said, like even in like my garden in Grand Forks County, I can see that free lime in the surface of the soil, but it's not negatively affecting my vegetable production because it's not soluble in the soil. It's not breaking down, and it's not causing salt damage to the plants that I'm growing there. Same thing with the crops and in the same area too.
yeah, I mean, if you were, back in the days of the Civil War when they salted fields, I mean, that the reason was to add salt to decrease crop production, right? And that was a way of controlling the food supply. And so, but in the southwest part of the United States, you also get 50 to 60 inches of rainfall a year. And so that washed through. And then, I'm sure after a couple of years, it was fine, back to its normal productivity. And so the problem that we have is that, as we stated, not enough water to leach things down. And if you do leach it down, the atmosphere demands a lot of water, so everything moves back up again. And so that's a challenge that you as agronomists have to recommend.
So I think that was a really great conversation about salts, but so often we hear this idea of what sodic soils are. So really, what is the difference between a sodic soil and a salty soil?
Okay. So we use, I had a conversation with John Lee, the great John Lee from Advice, and he had someone call one time and said that his soil was sour. And perfectly fine, a regional term, right? But it took John a half hour to figure out if his soil was what we would consider to be sodic or saline, because sour was the term. And so if you look at a soil test report and you have done on that soil test report soluble salts or electrical conductivity, whichever lab you're using, and have them run a test for base saturation. And so what we would normally see is that if a soil has a percent sodium in that base saturation that's greater than 5, and if that soil has an EC, or a soluble salt, of less than 1, we might consider that soil to be getting close to the fact of being sort of in that sodic sort of range. And what that means is that you have a lot more sodium in comparison to calcium, magnesium, potassium. And so what the problem with sodium is that it likes to be hydrated. It likes to be surrounded by water, right? It's kind of like a rock star that has a lot of people around them all the time, right? They like to be hydrated with people. And so, whereas calcium tends to be a little more of an introvert, but likes to be coordinated with just a couple people. And so that calcium on the exchange sites coordinates with the internal matrix of the clay and holds it together. And so it's a flocculant. Whereas sodium likes to be hydrated and it can't hold that clay sheets together very well. And so the clay sheets tend to repel each other. And then that's when you get sort of like the swelling or dispersion. And so that's why, but it's largely regulated by the overall electrical conductivity of the soil, or the soluble salt content. You can have a soil with like a really high concentration of sodium, but if the electrical conductivity is high, not a problem. The sodium isn't the problem, it's the high electrical conductivity. But that's what helps keep the clay sheets together, is just the chemical potential, if you will, of the inside of the clay sheets and the outside. And so when you have what Sarah's describing as a sodic soil, you will oftentimes see the soil particles, the clay particles, repel each other. And when they repel each other, they kind of break apart. and then they'll kind of move down through the soil profile over time. And that's oftentimes what you'll see is what we call is a zone of accumulation of clay and sodium. And so they're a lot easier to sort of think about from the standpoint of being separate from saline soils because they develop differently. But unfortunately, they get kind of lumped together into sour or sick or something like that. And then it becomes a little more complicated to just kind of tease out what they are. In Grand Forks County, Walsh County, most all of those soils are probably what we would call both saline and sodic. They have a high concentration of sodium, but they also have a high concentration of salt. And so we just kind of lump them into that term. So
say if somebody has a combination sodic and saline soil, how should they approach managing that? What should they tackle first?
Yeah. So the first thing is to manage the water. And so likely those soils that have those conditions also have a high water table, or historically have had a high water table over time, which allows that water to wick up into the root zone. And then when the water evaporates, the salts are left behind. And so the first thing to do would be to manage the water, because when you manage the water, you'll manage the soluble salts. And when you manage the soluble salts, after that, that's when you can start to manage the sodium. And so you may have to add things like gypsum, which is a sparingly soluble salt, but it's actually fairly effective. It is the most common amendment to use for sodic soils. Do not add gypsum to a saline soil because you're not going to do anything.
So I think this is a really important point because people get confused as to where gypsum is appropriate and what it's appropriate for. If you have a high pH or a low pH situation, adding gypsum is not going to help you. If you've got a sodic soil situation, gypsum is going to be the amendment that is going to help you to manage that sodic soil situation.
Correct. And I have heard people trying to use beet lime and things of that nature. And the solubility of lime is just so low that you're basically just adding a bunch of particles, if you will, to that soil. And it might help with the trafficability or the tilth of how well you can till that soil. But at the end of the day, it's not the preferred amendment at all for sodic soil.
When I think about the solubility of, because I used to struggle with that too, like thinking about solubility. I remember talking about that in class, but I never really thought about why it was important or what was applicable about it. But like when I think about and describe to people lime versus like gypsum, I think about lime that's formed from like the crushing of all these clam shells and ocean mollusks at the bottom of an ocean, right? And then over time, as millions and millions of years push them together, you get this limestone. But like you think about it, if lime is made out of the shells of these ocean critters, they're going to be made out of something that isn't very water soluble, or like it doesn't dissolve in water because they're living in these things, right? So that's how I always remember about like why lime is so insoluble versus something like gypsum that is relatively more soluble.
Yeah, I mean, it's relatively more soluble. Not very soluble, but it is more soluble. And so, where do we get gypsum? North Dakota is blessed with energy resources, right? I mean, we have our coal, we have our natural gas, we have oil, we have wind. We haven't seen any solar farms come in. That can be a topic for a side conversation. But in 1990, when the Clean Air Act was brought into play, the coal facilities had to scrub out the sulfur from the burning of our coal. Because we have to remember that all this work to get coal is to basically evaporate water to drive a turbine, right? And so we have to remember that that's why we get the coal. It's not just because they're burning coal, but it's to evaporate water to move a turbine, right? And so they had to scrub out that air. And what they do is they use what's called forced wet oxidation. Basically, they put calcium carbonate, again, using calcium carbonate, and they would actually use that to then pull the sulfur and the mercury in a way out of the stack. And then they're left with a product that they have to do something with. And so the Leland Olds plant in North Dakota has converted that calcium sulfite to calcium sulfate, which is now used in our agricultural production.
And that's kind of the same process of like beet lime too. So like for anybody here in the valley that uses sugar beet lime to control aphanomyces or maybe increase tilth, or if you're using it to haul back to an area with low pHs to amend the soil, just like the calcium oxide is used or like the lime is used to scrub sulfur from the smokestacks, the sugar beet processing plants use that calcium carbonate, that lime, to refine the sugar. And then we're left with a byproduct at the end that we can then use out in fields. So it's kind of the same thing, but a little bit more intense in the energy process coming out with gypsum at the end.
It would be remiss of us to overlook drain tile when we're talking about sodic and saline sodic soils, right? You know, Dr. DeSutter, you were talking about managing the water and really needing to manage that water if we're going to manage salts. So drain tile, as we previously discussed in the previous episode, that is an excellent way of trying to manage water coming into the surface in areas where water is actively rising to the surface. Well, in sodic soils, that can certainly create some challenges where if you've leached all of the other salts besides the sodium out of the system, you can be left with that sodic soil, which in essence can end up sealing up to itself if we're not going to try to remediate that some way. So how do we manage that?
I would say the first thing to manage that is to monitor through soil testing. And so that's the main way that we identify some of these, lump them into this category of problem soils, whether it's acid, whether it's saline, whether it's sodic or whatever. But yeah, soil testing, annually soil testing in the same spot. Now, of course, if you went to the same spot and there's a hole, move over a little bit and sample that, right? But yeah, the annually sample. And I think, some of our longest term data is actually collected by AgVice. They had a very strong foresight in trying to figure out if tile drainage was working. And it has over time, but it's taken years, right? And so, but yeah, annually soil sampling, speaking with your agronomist or speaking with your soil testing lab, knowledgeable people about the topic. You can call us. We have 2 new extension faculty that are coming on board, Dr. Carlos Perez and Dr. Brady Gadel. And so they will also be available to answer any of these questions. But yeah, annually soil sampling, monitor over time. If in fact, when that ratio of your base saturation % sodium becomes out of line with your electrical conductivity of your soil, that's when you would have to consult.
And I would want to say too, when we talked about soil testing for tile drainage, when I was working at AgVice, one of the things that we try to convey to folks too is that it's important to sample to the depth of tile as well. Not because like if you're doing a 1 foot sample and figuring out what the acidity and the salinity of that 1 foot is, it's good to know, and it may be indicative of what's below. But most of the time we're putting in tile line much deeper than a foot. And so it's going to be important to know if you've got any acidity problems farther down where that tile line is going to be and where that water is going to be flowing to as well.
Yeah. I think on an annual basis, maybe you could just stick with your, 0 to 6, 6 to 12, or, 6 to 24. But periodically, maybe every 3 or 5 years, make sure you get to depth, right, to monitor that. And certainly, we know that with gravitational water, that means the water that's going to move down through the force of gravity, that's going to carry salts with it. And it's probably going to increase the concentration of salts to depth at some point, leaving the top part maybe less salty, if you will. And so that's the area that you want to make sure that you can handle. It's really, really difficult over time to manage things you can't see, right? And so taking care of what you can sample regularly is key.
So when you were talking about that soil testing level where we really need to make sure that we're in consultation, again, that's that 5% sodium on the base saturation, or?
Correct. Yeah. And so I'm just visually looking at the AgVice soil test report. And on the lower right-hand corner, you have what's the % base saturation on that. And so just by happenstance, probably Mr. Deutsch put 0 to 5% on that sodium. And actually, through our research, through actually a good friend of Sarah's who did a lot of the work, Kathy, we determined that 5% was really kind of the limiting factor. And so anything greater than 5% should be paid attention to greater than anything less than 5%.
And I also, before we end this conversation, I also want to make sure that I'm bringing us back to that study that you were talking about that John Lee was doing with egg vice for all those years, because I've followed that study for a number of years as an agronomist, constantly getting continuing education. There was a field not so far away from Northwood, the soil sampling lab that John was associated with egg vice. And there was a part in that field that was saline sodic, and then there was also areas in that field that were saline. And they drain tiled that, and they did remediate or apply gypsum in conjunction with that drain tile at that point in time. And the crop production on that was okay at that point in time, but it was watched very carefully, and it was soil sampled very carefully. So from a real standpoint, if you are in a situation where you have a saline sodic soil, you can manage that effectively and actually drain tile, but you need to be careful that you're being very diligent about how that's being handled.
Yeah. And, our phone lines are always open. We hope that people utilize us. We are here. We are part of the land grant mission to bring education out to our stakeholders and to answer those questions just the same. But we have an exceptionally high number of very, very, very good at crop advisors in this state. And so I think that's the one thing that we're blessed with too, is like we have an exceptional group of crop advisors in this state. And so if you have questions, please consult your crop advisor if you have one.
And I think that goes back to having a lot of the crop consultants in the state went to NDSU, and they were able to take classes like soils and land use from professors like you. Again, we appreciate so much the time you took with us today, the pedagogy and the teaching that you give to students at NDSU. And
thanks for putting up with us in your class. I really appreciate that. When Tom started teaching our class, he began saying, "Oh, good, this is where you're all sitting. Once I get you memorized where you're all sitting in this room, you'll be sitting in here forever." So near the end of that semester, I walked in before Tom was there, and I said, "Okay, everybody, let's switch spots today." And it was the day that he had to hand out papers. It was great.
So that was I remember that vividly. So I joke, ha ha, that the only reason I give homework is so I can figure out their names. And so now everything's online in a sense, so it's not as much fun. But yeah, I never really graded them. I just wanted to hand them back to see what your names were. So
all of you aspiring teachers, take note.
Yeah. So I don't always remember students' names per se, but I know where they sat, and so that's how I sort of relate my experiences a little bit, is like the visual, the memorization of like what was happening during that time. And, it goes back to, we know exactly where we were when 9/11 happened, right? I mean, exactly. And so I try to bring that into the classroom just so I try to remember everyone, because sooner or later, a student's going to come up and say, "Oh, do you remember me?" And most of the time I can say honestly, yes. And say, "Oh yeah, you sat back in the left-hand corner by the window. I remember where Jody sat. I remember where Sarah sat." And so.
Well, thank you so much for joining us today. This would end the previous episode as well. It was a great conversation. It's always fun geeking out with you about soils a little bit and just how we see landscapes and everything. So thank you.
My pleasure, and I hope everyone has a safe cropping and harvest season in the future.
Thank you so much, Tom. And with that, remember, with GK Technology, we have a map
and an app for that.
And I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture. so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.